This is IMO 1976, question number 4. The question wants us to find the largest possible value of product of positive integers, where these positive integers, when add up together, equals to the sum 1976. So we're given the number 1976. We divide this integer into a number n of integers, a1, a2, up to an. And we want to find the largest possible value of a1 times a2 up to an. For example, if we put n equals to 1976, so n number of these ones, when add up together, equals to 1976. And the product of these ones equals to 1. We can divide 1976 into two parts, 1 plus 1975. And the product of them equals to 1975. We can divide 1976 into two parts, 1000 plus 976, and get a larger product. A better way is to divide 1976 into three parts, 500 plus 500 plus 976, and we get a much larger product. And we want to get this product as large as possible. So, say we divide 1976 into n integers. Some of these integers may be equal in value. So the product becomes ak times a1 times a2 up to an. We call this value p1. Now, if this is one of the possible division, we replace the term ak by two terms, which is ak minus 2 and 2. Then the product of these two parts, ak minus 2 and 2, is 2 times ak minus 4. If ak is a value larger than 4, then 2 times ak minus 4 is larger than ak. So, by such division, we get a larger product. Since ak minus 2, close bracket times 2 is larger than ak. So by such strategy, we divide any one of these terms with value larger than 4 into two parts, and we will get a larger product, p2, which is larger than p1. So we can divide 1976 into a number of 2's plus a value bk to obtain a larger product, bk times 2 to the power x, where x means the number of 2's we can find in 1976. So this is one option. We can further consider by dividing any one of these terms, say ak by two terms, as ak minus 3 plus 3. The product will be bracket ak minus 3 close bracket times 3, which is 3 times ak minus 9. If the term ak is a value larger than 5, then 3 times ak minus 9 is larger than 2 times ak minus 4, which is larger than ak. So, this would give us an even larger product. Since bracket AK minus 3, close bracket times 3, is larger than bracket AK minus 2, close bracket times 2. So this value, we call it P3, is larger than P2 or P1. We indeed get an even larger product. So a better way is to find how many frees can we obtain by dividing 1976 into different parts, plus another term, CK. And the larger product will be CK times 3 to the power Y, where Y means the number of frees we can find within 1976. So, we just considered how to split up each term into two terms. If one of the term AK is larger than 4, we can split AK into 2 and AK minus 2 to get a larger product. If AK is larger than 5, we can split it up into 3 and AK minus 3 to get an even larger product. If AK is larger than 25, by the same rule, we get 4 times open bracket AK minus 4, close bracket, larger than 3 times bracket AK minus 3, close bracket. That means by replacing AK by 4 and AK minus 4, these two terms will get an even larger product. However, we may not divide this term into two terms. We can even divide it into 3 or more terms. If AK is larger than 25, certainly we can get a final division to replace AK into 3 or more terms. The finest possible division is to divide a term into 2 terms. So, we only need to consider the case of dividing each single term, say AK of J into AK of J minus 2 and 2, and AK of J minus 3 and 3. With the division AK of J minus 3 and 3 preferred, as that will give us a larger product. Since 1976 contains a number 658 of frees plus 2. So, the largest such product we could obtain is the value 3 to the power 658 times 2. And this is the answer.